Class, you're all welcome. We are going to continue with our examples on vectors. Okay, we're going to solve more and more examples. All right, this topic is a topic that requires a lot of attention. Yes, it requires a lot of attention. So details are very important for you to do well in this topic. It's a very important topic. Please take note of that. Now, with this question, you see, before I start, let me explain what collinear points are. Collinear points. So when I say collinear, what do I mean? Okay, collinear, when three or more lines are on the same straight line, they are said to be collinear. So for example, if I have a straight line like this, if I can call here P, here Q, and then here R, then they are on the same straight line and they are called collinear points because they are on the same straight line. Otherwise, you cannot call them collinear points. All right. So straight lines, a straight line, 3 points on the straight line are collinear points. Or more, I can add more points, many points. And no matter how long the line is, the points on it are collinear points. Co, they share. It means to share or common to them. All right. Something co comes from the word togetherness. Okay, or together. Right. So now let's move on. P, Q, and R. When three lines are set up like this on a straight line, what comes to your mind? You can see clearly from here that P and Q, PQ like this, makes up a line, right? Is a line, is parallel to QR. Yes, they are parallel. And we can also say that PQ, like this, is a line, is parallel to PR. Yes, that's true. Yes, that's true, right? And remember what I taught you in the first video, I think, or second video. I said when two lines are parallel, they form vectors that are multiples of each other, right? For instance, PQ is parallel to QR. Since line PQ is parallel to QR. So the vectors they form, this implies that vector PQ now. See, I'm writing vector now, vector PQ, like this. This is a vector now, right? You can see the arrow now to indicate that it's a vector, must be equal to some number times, if I like, I use lambda, right? Times QR. I gave you this. Okay. That's the first thing that comes to mind when two vectors are found to be parallel, right? Vector PQ is parallel to vector QR, and that means that there is a constant that you multiply QR to give you PQ, all right? Or vice versa. You can reverse it. QR is equal to some constant times PQ, and so on, right? So this is the right thing to do now. Okay, I can use this one now on this because now I'm given that I want to show that P, Q, and R are collinear if I'm given these vectors, right? I want to show that. So now to show that they are collinear, I have drawn this. Let me see if one is a multiple of the other. If PQ is a multiple of QR, that is essentially what I'm going to show right now. All right. Okay, let's see the solution. Solution now. Okay, you see, I gave you this again. I said PQ, vector PQ is always the same thing as vector OQ, writing it now in terms of the position. These are position vectors now, right? OQ minus OP, like this. See that? And the other one, let's say QR now, vector QR is equal to vector OR minus vector OQ. Remember that, right? This is what I taught you. But OR, first OQ, like this, vector OQ, can simply be written as vector Q, small q, like this. And I can write OP, vector OP, can simply be written as vector P, because these are position vectors now. Okay, then OR, vector OR can be written as vector R like this. I can write it to simplify my work. I can write it like this. All right, so now I can go here and begin to substitute all this into this expression, right? We have since PQ is parallel to QR, since PQ is parallel to QR, this holds. Now, PQ must be equal to some number K times QR. That is it. That is simply because I want to show that they are collinear points. Okay, now this one becomes Q minus P like this is equal to K bracket R, vector R minus vector Q like this. I can do it like this. I can do it like this. All right, but vector Q is given to me because OQ is given to me. Can you see? OQ is given to me as 5A minus 5 vector A minus vector B. So I have it 5 vector A minus vector B, right? Then minus, let me take this in the bracket, minus vector QP is given to me. That will be OP now. That will be OP 2A vector 2A 2 vector A minus 5 vector B. 2 vector A minus 5 vector B like this. See, this would be equal to now K. K is a constant. Bracket vector R is given to me as OR. Let me find OR. This is vector OR, which is the same thing as small r, vector small r. 11A plus 7B. 11A plus 7 vector B. They are vectors. Okay, let me do like this. Let me do like this. Big bracket. This is 11. All right. Then minus. Take the other one, which is Q. Vector Q is also given as where is it? OQ. Okay. 5 vector A minus B. 5 vector A minus B minus vector B. All right. Let me close this bracket now. All right. Okay. Now I can simplify this. This would be 5A minus 2A, which is 3 vector A. Then minus vector B plus vector 5B is going to be plus 4 vector B. See, I'm done with this. So this is equal to K bracket. Now, this is 11 vector A minus 5 vector A, which would be 6 vector A. All right. 7 vector B plus vector B. That will be plus 8 vector B. Like this. All right. So we can see clearly, all I need to do is to show that one part is a scalar multiple of the other part. Simple. So I'm going to have 3 vector A here plus 4 vector B like this equal to, I can factor out 2 from here to give me 2K bracket 3 vector A plus 4 vector B. Now we are there. Now we are there. You can see clearly that this is the same as this. So this part is a scalar multiple of this. All I need to do is to be able to find what this is. Okay, this has to be 1. This has to be 1. This has to be 1. 2K has to be 1. Why? Because it is only 1 times this whole thing that will produce this, right? So this implies that 2K, or you can simply just cancel this and this. They can go off, right? 2K has to be equal to 1, which means that K is equal to what? 1 over 2. So this shows you that this P, Q, and R are collinear points. Why? Because we're able to show that this is some scalar multiple of this. All right? You can see I've extracted this one from this one. I can get it. You understand that? And that is it. And so we have found the value of K. But the other part of the question says we should find the ratio P to Q. Therefore, PQ ratio QR would now be equal to, you see, it's equal to K what? It's equal to KQR, right? K will be equal to K now. Will be equal to K. Or let me just take the expression from here. We have PQ is equal to KQR. So I can just divide through by QR to give me PQ over QR equal to K, which is equal to half. So I have found it. All right. All right, we take another question.